So in the last lecture I have shown you how to solve first order linear ordinary differential equation. So in this lecture I will show, or I will discuss a type of equation, a type of first order equation which is not exactly linear, you can say in general. So but we can always solve this equation with a little tweaking, and we can always reduce this thing in first order linear equation, and I will show you the method of reducing this equation to a linear equation. Okay, so this equation, you should always remember this thing, that dy dx plus pxy is equals to qx into y to the power n. So this equation we call it Bernoulli equation. So you see, this equation has very similarity with the equation we have introduced in our last lecture, that this linear equation. Okay, only there is a factor, that is y to the power n. This factor is there. Okay, everything is the same, just this factor. So this n is a real number. So if n equals to 0 or 1, this Bernoulli equation can be solved very easily. How? If n equals to 0, you put here y to the power 0 becomes 1, so our equation looks like this. You see, this is our previous equation, the previous linear equation which we have solved earlier. Now if n equals to 1, this thing becomes this. Now if you take this part and move it here, you will get dy dx plus px minus qx of y is equals to 0. This is a separable equation. You can separate out y part and x part. You can solve that. This dy dx plus p minus q of y is equals to 0. This both p and q are function of x, so you can write it in this way: dy by y, okay, plus p minus q, they are functions of x, dx is equals to 0. This is n equals to 1 case. Okay, you should remember this thing is separable thing, or you can separate out this y and x part and you can always integrate out. Okay, so now we take the cases when n is not equals to 0 or 1. Then how to solve this problem, or how you can solve this? So this is a very small step but very important step. So what do? So you remember, this x is called independent variable and y is called dependent variable. So we change this dependent variable. Okay, and how to change this thing? We take another variable v, which we take as y to the power 1 minus n. You always remember this transformation. Okay, so we take this transformation to change the dependent variable. So we had dy dx, so now we need to find out what is dv dx, because we will change this whole thing, change the all dependent variable y in terms of v. So we have to find out what is dv dx. So dv dx, if you integrate out this thing, this is a very simple integration. I think you all should, or you all can do it very well. So this dv dx will come this thing. Okay, this is a very simple differentiation, I guess. Okay, so now if you put this thing here in this equation, in this equation 1, so you will get so just before putting, we just add another step, that is, we just multiply both sides by y to the power minus n. So the left hand side becomes y to the power minus n dy dx plus px y to the power there was y was there, so we are multiplying with y to the power minus n, so this thing becomes y to the power 1 minus n. Okay, and this thing will become q of x becomes y to the power minus n, and y to the power n cancels out. So now you can see that you can replace y to the power minus n dy dx by 1 by 1 minus n dv dx. Okay, you see these two things, we have replaced this thing by this thing. That means we have taken this 1 minus n factor to that side. Okay, so and now we have written this thing is equals to, this thing goes that side, that means 1 by 1 minus n dv dx is equals to y to the power minus n dy dx. Just you get those things, they are equal. Okay, so now dx is there and y to the power 1 minus n, you see we have taken v is y to the power 1 minus n, so we have replaced y to the power 1 minus n by v, and left hand side, sorry, right hand side, qx remains there. So now this equation, this last line, and again you see this can be written in this form, dv dx 1 minus n, you just multiply out this 1 minus n, 1 minus n, 1 by 1 minus n factor to that side, you will see that becomes 1 minus n factorials come here and here. Okay, so the whole things becomes dv dx p1x v equals to q1x. So what is p1x? So p1x is nothing by 1 minus n into p, and what is q1x? q1 of x is equals to 1 minus n into q. So I have written this p1 and q1 purposely because you see that this equation is again a linear equation in v. So if you remember this linear equation by which we have started our previous lecture, this dy dx plus pxy equals to qx, the same things would come. So just we have v in place of y, so we have changed the dependent variable. So this is a linear equation in v, so you know how to solve any linear equation and I have shown you. So this is the ready-made answer. So I think this thing you have not happened to remember, this is very easy and will come from the previous theory. So just you have to just do the sums. So for we have taken this sum for example, this is dy dx plus y equals to xy cube. So you see this form or this equation is not in linear equation because the right hand side there is a factor y cube. Okay, so if we compare this thing with this equation, with this Bernoulli's equation, we see that px equals to 1, qx equals to x, and n is 3. So our integrate, so how to change our dependent variable? So this is the formula, v is equals to y to the power 1 minus n. So n is 3, so we have taken v is equals to y to the power 1 minus 3, that is y to the power minus 2. So if you just differentiate our this v with respect to x, you will get dv dx equals to minus 2y to the power minus 3 dy dx. You know v equals to y to the power minus 3 minus 2. If you differentiate it with respect to x, you will get this relation. Now put in the main equation in place of dy dx and simplifies the out this thing. But before that, we will do one thing. We just multiply by y to the power minus 3 both sides. So the first part will come in this way, second part will come this way because there was y. So if you multiplying by y to the power minus 3, that will be my y to the power minus 3 into y, and the right hand side become x. So now if we replace this thing from this relation, you will get minus 1 by 2 dv dx, minus 1 by 2 dv dx, this thing. Okay, this thing is this, and y to the power minus 3 into y, that means y to the power minus 2, and you know y to the power minus 2 is equals to v, so put it here v, x is there. So if you simplify this thing, it will become dv dx plus minus 2v is equals to minus 2x. So this is a linear equation, and I am sure you can solve this. So what is integrating factor? You know, integrating factor is e to the power minus integration minus 2 dx, and it is e to the power minus 2x. So you just multiply it out by this e to the power minus 2x, both sides of this last equation, and if you see that this left hand side is exact, and this thing is v into e to the power minus 2x, and the right hand side you have to perform the integration. This right hand side is e to the power minus 2x into 2x, minus 2x was there, so you have to do this integration, and this integration will come this thing, and the left hand side, if you integrate out, it will become v into e to the power minus 2x. This left hand side is always simple, because you know this left hand side is always this variable, this independent variable into this integrating factor. It will always become this. So this thing, and just in the last line we have again replaced v by y. So you know the back substitution, you know v is equals to y to the power minus 2, that is 1 by y square. So we have put there 1 by y square in place of v. So this is our final answer. Okay, so I have given you particularly another 2 examples, so you can try yourself. So these are very simple examples, and Bernoulli equation is very important equation too, and solving this Bernoulli equation is actually very easy. So you have to just remember this transformation rule, this v equals to 1 by y to the power 1 minus n. You will use it everywhere when solving Bernoulli equation, and this equation is nothing but you have just reducing this non-linear equation by changing to a linear equation by changing the dependent variable. Okay, so that's it. So just solve these 2 problems for practice.